in your trials, whereas if you like you get more computation,
Or digital twins.
yeah, you have an issue. Well, yeah, decisions. Sounds like
Yeah.
but
Yeah,
I need to go faster outcomes.
I think everything is going to trend towards like modeling simulation. Yes. But it's just a matter of like, especially if it's like an hybrid, it's going to like towards the end, or towards a normal thing.
I mean, it should be regulated, but
Yeah.
I mean, you play with this. Like, who should? I don't know what the hell. It's delicious.
I'm gonna eat it though. It's not gonna stop.
are you ever studying? Are you ever studying PhD of mail?
I don't know. Wait. Okay, hold on.
Or for 2 minutes and then we'll start.
Yes.
Yeah, you are. Okay.
You know both of us. I'm Logan.
I'm pronounced.
हेलो
Okay, you didn't say your name.
भाई ये क्या स्कैम क्या चल रहा है ये सामने
Okay, okay.
Yeah.
I was like,
मतलब आइडियल में वो प्रॉफ नहीं पढ़ा रहा कि सुबह सुबह
Let's meet up anytime next week to discuss how we are progressing.
I have the not, I guess not ideal setup, 'cause I don't know. But I'm getting like 79.
What else? I've been checking is cylinder, hourglass.
Pyramid. So like wide to narrow.
And how many million parameters you use?
23.
Okay, almost.
Yeah.
Using the robots?
I didn't do dropout yet, so I'm figuring like I could probably get there
Yeah.
with my architecture.
If you use some robots, are you using Bashma language?
I didn't use any of it yet.
Oh,
So I'm getting 79 without anything.
oh, then you get it.
We can just enough that for 5 minutes to see if more people join in.
So I'm hoping I can get it.
Yeah.
But like, I switched to diamond architecture. My accuracy went down. It's trash.
Yeah, guys, I think you were just waiting for 4 minutes and then we'll start.
Reach out.
Okay.
And what's your application?
Sorry?
Application from?
Oh, I was using Galio. Yeah.
How many minutes?
I mean, I haven't run that shit overnight.
So you run like 100?
No, I have like 20 epochs. But my first layer is like 4,096.
Okay.
And then they
Gives good enough. But yeah, I think if you just run it for 100, that's the realization technique.
And what?
Yeah.
Okay, so I'll just run it for the next week.
No, it should only take you 15 minutes for it.
Oh, wait, but
You got 1 day on it.
I didn't, I'm using the C4. So if I switch to A4, if I switch to A100, I should be all right.
Is audio being?
Yeah.
Okay, so should we stop it before the lecture starts?
No.
Okay.
How much is your battery?
My mass charge is 4,096.
Maybe you'll go to see why it's so.
Basically, if your per epoch is taking like something around say half an hour or so, that's because the iterations per second mixed precision training that can help you out. I was facing the same problem.
Thank you so much. Wait, did you already get above 86?
No, I'm stuck at 85 and it's annoying. Frustrating.
So yeah, just send me a input file and I'll have a look at it.
Okay.
Yeah.
Alright, cool.
They must not be any.
I put 2 models in, so instead of like changing, because I know this model works, just get another one.
Yeah, that's fine.
Okay.
Just send me an,
Like this one is difficult to follow on because if I'm sharing something, they won't be able to see it and follow it.
Yeah.
Right?
No, let me see.
Yes.
Here, check it out.
Yeah, this is the draft.
April before. The worst comes to worst, I guess we can use that.
Yeah.
And then I'm thinking like, a neutral purpose.
Yeah. It's not even worth putting there, I'm just like, get neutral.
It's still worth putting it in, because we can.
Okay, guys. Hello, everyone. I think we'll be starting our lab. Hello, everyone. I'm Kate, Ishan. We have another TA who will be joining us in a minute. Today, we'll be covering a very important topic about how to debug your neural deep learning networks and also how to interpret everything you're getting from your network, like all the charts, all the information. It'll be very helpful because it helps you a lot during modeling and during doing all your homeworks. The very first idea is, so you know in computer science, debugging is a major part of work when you have to debug all the code you wrote. In deep learning, it's even harder, I would say, because there's so many different parameters you can track, you can change, and then it makes it really hard. At the same time, sometimes deep learning models will fail silently. You would think they work. There is no errors at all in the code, but at the same time, the performance is really bad and how to debug this. And all of this we will be covering today during our lab. So we'll try to provide you with some tools and guidance, how to go step by step in the process of your homeworks and how to debug the neural nets. The lab overall will be structured in 2 parts. So the first one will cover how to debug part 1. Ishan will be doing some live demo with interesting tools, and then we will go to part 2 and go step by step through different processes, how to debug that part as well. Okay, so the first one is homework part 1. Just going the floor to Ishan. Yeah.
Yeah, could you open the chat so that? Yeah, can everybody see my screen with the VS Code on? Just to get a confirmation from people on Zoom. Oh, yes.
Yeah, we can see that.
And then dim the lights a little bit.
Right. Is that okay?
Yeah, is there any way you can dim the lights at all?
The
I
lights
think your
at all.
lights over here.
I'm not really sure.
I can get it. Okay, thank you.
Thanks.
Okay, perfect. Thank you so much. Yeah. All right. So to start with debugging for part 1, right? I'll be covering debugging for part 1. So in debugging, it's like oftentimes what I've seen in the office hours or in person is people run into these problems and bugs, and they're not really sure what to do, right? So the first instinct is naturally, for example, we will be using homework 1 part 1 itself so that you have a reference point and that you can follow along as well, right? So yeah, in case you don't have your laptops out, y'all can just take them out and follow along as I'm doing as well so that you all get a hands-on of the steps I'm saying. I understand people on Zoom may not be able to do this, but please look at the instructions properly and you can perhaps try to emulate it later after the recitation as well. Right, so for example, now in our situation in VS Code, ideally you would like to open the folder in which your entire homework is situated, right? So that should be your first step so that all the files are very accessible when you try to run them from the terminal, for example. Now, say you want to develop the linear function, right? And you were developing it, you were creating it, and you somehow seem to run into an error at this line, right? Perhaps maybe the shape of W was wrong or B was wrong. So say it was like this, right? You go to the autocrater and you try to run it. What happens is it gives you an error But it's like, wait, why? Why did that happen, right? So what you can do is, what I've seen people do is they will try to print shapes, right? They will print shapes of W, they will print shapes of B, but they may not really realize where the problem lies. And it is really inaccessible when you're printing statements to get the shapes of each one at a time, which is why what we want to show you all how to use today is the debugger built inside VS Code itself, so that you can really interact with the code as you're running it, right? So, yeah, for example, you know that if you know that your error is coming, say, from example, line number 35, but it's a big equation and you don't really know which part of the equation is not working, what you can do is, when you open VS Code, what you can realize is, when you move your cursor to the left, you see this red dot that's moving along. That is something that is called as a breakpoint. If you want to set a breakpoint at step 35, at line number 35, all you do is place the red dot, and then you try to run the debugger. Now, coming how to run the debugger itself. You don't simply run the file from here because, as you may have known, running the autograder is the first step to call this file. But to run the debugger, what we do is, to the left side of the screen, you have this option here, run and debug. If all of you guys are following, it would be great if you could do this as well with homework 1P1. Like, just as a show of hands, are you guys here trying to follow along? Perfect, yeah. So if you can see this run and debug button, you should go there. Now, if it's the first time that you're using this, you will see sort of this window where it just says run and debug. And you might think clicking on it would make it work, but nothing would really happen. So what you need to do is first, if it's the first time you're doing it, press on create a launch.json file. And you will have this prompt here. Select Python debugger, and then select Python file, right? And so you'll have this new blank launch.json file. You don't really have to do anything here, but now that it's created, we will be able to run our debugger properly, right? So you just close this file. All right, so how this debugger works is, we have it set to current file. That is the default option that comes. So make sure that the file that will call your entire Python functions is open. So you don't want your linear.py to be open and then try this, because nothing really would happen. You need to ensure that the autograder file itself is open before you press this, right? And once you're here to start the debugger, you press this green play button, and it sort of goes step by step. And as we see, it automatically triggered it to break and stop where we had set our checkpoint. Unlike running it normally, the difference here is that we can now interact with the code at this stage and interact with all the variables that have been stored and created at this point. So now that we have the breakpoint here, let's first sort of go through this window and understand what all we have available to us, right? So to the top, we can see variables, where we have a list of all the variables that have been currently created, generated, and are accessible to the code itself, right? So we can see that variable A is sort of coming from here in the forward function, and the rest of them are inside self. So yeah, you can see self.a, self.n, self.1s, self.w, self.b, right? All of the ones inside self are present here. And if you just want to understand what it actually is, you can hover over it and you will be able to see a preview of what the variable actually is. So not just sort of the truncated version of what it says, like -4, -3, but you can actually see the entire value of the function. So that is what you can do from here. And watch. If you wanted to watch for any particular variable, you could just do a plus here, right, A, and you can always keep a track of the variables. So for example, there is one where you know that the shape is going wrong or you don't understand how to implement it, you can set it in watch and always keep monitoring it as you're progressing through your code, right? Another thing to note is when you put the breakpoints here on line 35, it breaks before line 35 itself is processed. So right now, this equation hasn't been run, and we are right before it is run, which is why we didn't run into an error. Because as you can see, there's a shape mismatch, right? So if we were to go forward, it would definitely give us an issue. We are here at this stage knowing that line 35 will have a problem. So let's try to fix it and try to figure out how we can fix it. So yeah, when you sort of bring this terminal, one second, yeah. In case your terminal is not visible, you can just hover your mouse to the bottom of the screen and drag this up. This is where you sort of get this window where you can see all of these options. Usually we use terminal, but now since we're in the debugger, we have access to something called debug console, right? And this is where we can actually interact with all the variables and the code itself. So for example, if I wanted to check out the shape of A, I can just type a.shape and it works. I can do sap.w.shape, that works, right? And so if I wanted to check in particular if this equation would run, what I can do is,
Okay, real quick,
yeah, I'm sorry.
how do we actually get the debugger commands?
Oh, so which step were you on?
I set the breakpoint, looked at the JSON file.
Okay, all right. So yeah, we have a question on how to restart it, so I'll cover that quickly again, right? So if your JSON file is created and everything is set, you sort of open the file that is the main trigger file. So for homework part 1, it's always the autograder, right? So keep the autograder open. On the left-hand side of the screen, you will see this option, run and debug, right? By default, usually your Explorer is on, but you can click on run and debug, and then you should be able to see this with this green arrow here,
Oh, okay.
right? Yeah, when you press that, that is when your debugging starts, and it will naturally go and stop at the breakpoint. Yeah, no worries. All right, so while we're here, when we know that there's a bug in this line, we can simply copy it and paste it in the debug console and try to see. And yeah, it tells us that there is an error. But again, it's not exactly specifying which part of this equation the error is in, right? So you can even run bits of this equation to make sure everything inside the equation is correct. So let's look at the second half. It works. So now we can comfortably say that the error is probably going to be in the first half. So since we already printed out the shapes earlier, probably we can understand that, yeah, there is going to be an issue here, right? So for example, you could directly copy it first and try to see if that runs. It doesn't run. So now we definitely know our issue is in this one particular part of this code and this equation on line 35. And what you can do is, since it's interactive at this point, you can make modifications to this equation and see what can make it work, right? So np.self.a self.w, it doesn't work. Why? Probably because there's a shape mismatch. So you can look at the write-up, try to understand the shapes, in addition to printing them out here, and try to figure out how you can get it to work. So probably transposing it would be the right thing to do. And here, that is all that we needed to get it to work. So what you would tend to do is directly try to modify it here, right? But now if you do try to continue, it would still run into an error. So for example, at the top, this is your controls here, where you can sort of press step over to go to the next line. It still runs into an error, right? But we just put the transpose back in. So the code doesn't get modified online. We can add and make changes to the code file itself, but to run the modified code, we need to restart the entire debugger file. So we press the green arrow here, and now it is going to run along with the transpose inbuilt, right? And we moved on from there. So now we fixed the issue that we had and proceeded to the next step. So that is basically how you would be able to interact with your code and just go through it step by step. So just to give a brief description of what this control panel itself does, there are these 6 buttons, right? So the first one is play, where if there is, it'll directly play all lines of code till the next breakpoint. Since we don't have any other breakpoint, if we press this, it would run through the entire code itself, right? And then if, say, we want another breakpoint in backwards, for example. If I was to come back to autograder again, run it, it'll naturally stop at the first breakpoint. If I press continue, it'll process all the code and then directly stop at wherever the next breakpoint is in whichever file inside the entire stack that we have. Coming to the second button, it's called step over, where we directly step over to the next line of code, right? So as we see here, if we want to go step by step manually as well, instead of setting breakpoints for every line, you can set a breakpoint at the start of wherever you want to investigate and debug, and then you can press the step over button to go to the next line. Suppose your line was calling a function itself and you didn't want to process the function. That is where you can do step over and it will directly try to process the entire function and move on to the next line of code But if you wanted to investigate the function itself, you can try to use the step into button, where you will then go inside the function and go through all lines of code inside that function call itself. And if you want to exit that, you can press step out to sort of exit that function call if you realize there's nothing really that needs changes there. The green arrow is to restart the entire debugging cycle again. So if you make any changes to the code and want to see if it runs, you can press this green arrow and it'll just restart the debugger cycle, and you can keep doing this iteratively. And the red stop button, that should be explanatory, but yeah, if you press that, the debugger is stopped, and now you can just try to run the autograder normally through your terminal as well to make sure that everything works, and you pass the tests. So if you just do this, we pass the test because we fixed the error, and that is pretty much how you would go about identifying where the error lies and try to understand it, investigate it, and fix it, right? So did anybody have any questions in this general process that we had? Any questions in Zoom?
What JSON file were you talking about? Like, what is the part of the JSON file?
Okay, all right, yeah. So, yeah. If it's your first time using this debugger, you will probably not have this launch.json file. Okay, so it's like ideally if you've opened up the folder where you want to do this debugging or where the assignment lies, you won't really have it. So what you should do is if you go to run and debug, you'll have this interface. And if you press this, nothing really happens. So the step one would be to create a launch.json file. Go to Python debugger, Python file, and it automatically creates this launch.json based on a template. Launch.json is a very powerful tool, and I would definitely recommend you all looking into how to use it when you want to run, like when you have a code base which has multiple files together, so that you don't always have to write given the terminal commands, because some functions may have a lot of input arguments that it expects, right? So when using launch.json, you can sort of pre-configure everything and have like pre-configured terminal execution code for 5 or 6 files and functions, right? And that really makes it easier to test different files together. But we don't really need to worry too much about that for this. It automatically generates this template for launch.json. And once it is here, if you go to debug now, you will be able to see this UI, and you will be able to press this green start, and that is how you can start the debugging. Yeah. Any other questions about any other step in the process? All right, if that was it, I guess we can proceed.
Okay, what exactly do you need? Give me a second. Can you just- Ready?
Yeah. Let me just put slides first. Where are the slides?
You can start with this one.
Sure.
Yeah. So now that we looked at how to debug shape errors, that was like sort of syntax errors and some of the other issues that you might be facing in part one. Here we're going to talk about how to use PDB. I think in some of my office hours and the hackathons, I didn't help people set this up in terms of debugging it, because when you're debugging, I see so many posts about, summary not going wrong and other things like that. For that, using this tool is much better than using a print statement and then figuring out from there. So PDB is like a debugging tool which sort of helps you to investigate variables on the go, similar to how you would do it in Visual Studio Code, but on Collab this works well. So every time, most of the time when a Python script fails, it raises an exception. So what happens here, let's look at a simple example. Give me a sec. Yeah, about a division by 0 error. And here you can see that that exception has been thrown. Some of the times you can see that most of the times you can see the trace that has been passed here, and it will most likely give you the error that has happened, and it might be enough for you to debug. But in certain cases, when you might not be able to identify what's going on, we use PDB there. Uh, and now let's look at an error code first before going to PDB. Let's look at an error code that you might have. Yeah.
Lucas, just zoom in and.
Yeah. Is that fine? Yeah. Yeah. So here is just a piece of code wherein we define a loss function. Give me a sec. This is kind of, yep. And once I run this, it shows me an error saying multi-target not supported. So here we can see that this error message right now, I think now when I wrote this notebook, it wasn't very clear to you at the beginning of the class, beginning of the semester. But now I think that it's more well versed at what might be happening there. Also here you can see that now when I run this code, which says division by 0, give me a sec. Yep. So the command that you can use here is basically writing %debug, which is kind of a magic command which you can use which opens up an interactive box wherein you can investigate the variables. So here you can see that it stops it at the point at which it raised the exception. And you can say print A, and it'll give you the value of 1, and then print B, the value of 0, which is the reason why you can see here that it's a division by 0. So I found this tool most useful whenever I'm doing my part 2s, because instead of every time going and writing print statements, this is kind of useful for this. And then you can also go to the next instruction, and there the next instruction was that the exception was raised, so it ended it. I'll come to that in the next time. And over here, you can also use the up and down commands. A sec. Yep. So here, if I were to go to up, it goes to the previous function call, which was here. And then down goes to the next one. You can also do down 2. And yeah, here it already ended it. So let's say I go up. Yeah, it went back to the function of 1 call, which was the original call. And then you can use Q to quit it. And in case you don't want to wait for the exception to be raised, you can always, whenever you're running your summary code, your architecture code, you can, especially in terms of like when you're writing in homework 2 part 2 and homework 3 part 2 and homework 4 part 2, wherein you have bigger architectures, using this tool becomes kind of important because you're stepping through each layer or each call in the forward, and this helps to debug that. So you can also do %pdb on, and that will open the same terminal that you just saw and the same commands that we were just speaking about. Give me a sec. Yep. And similar to how Ishan talked about breakpoints, zoom in here, give me a sec. Yeah. In PDB, you can set breakpoints by using the pdb.setTrace. This is what I use mostly because the stack trace in the beginning will tell you which line it failed at, and you can do the set trace before that, and then it would give you the different commands. It would give you another box like this wherein you can print out I, and then you can see that this has happened here, 0. And you can also do continue so that it finishes one more iteration of the loop. And now when I print I, it's going to be 1 because it's gone to the next iteration of the loop. And you can also do break to finish that. You can also do continue, next statement, and then print I. Yeah. So these are some of the commands which you can use here, and I found this to be very useful. Then I can just quit here, and a sec. The response time is slow on this notebook. Yep, and yeah, that should cover the PDB tutorial. I would strongly suggest using this because it has helped a lot in debugging instead of buggering your code with a lot of print statements. And some of the other commands here would be to use list, which shows the correct location, Help will give you a list of the commands, and then quit, continue, next we just spoke about, and then print as well as return, and also the step in order to step through the function. All right, thanks. Now Kate will continue.
Okay, great. So we discussed basically how to debug and what kind of tools we can use to debug part ones. Now we're moving on to the fun part with part two, which has like lots of moving parts. And the ideal workflow, how you're working on part two, is kind of very straightforward. So just load the notebook, you download it, you just go through the code, fill in all the to-dos, submission, make a submission like for very low cutoff, then like make some different experiments, reach the high cutoff. Very straightforward. And you would think that it would take like not as much time, but in the end you will discover you have so many different issues at different areas. And today we will be covering how to debug them. So if we just look at this notebook, we will see that there are multiple levels. So the first one is data load, and we need to load our data. Then we build in a model. Then we go and we train, we monitor, and then finally, when everything is great, we make a submission to Kaggle. And now we'll just go like part by part and think about like how we can make it better, more efficient, to achieve better results. So the first one is data loading and preprocessing. The very first thing that you want to like do when you're working on this part is literally open your file, your data, look at it, and just understand what are you working with. So in this example, you see a picture of one MFCC file and one transcript, and we can see that basically this is the data you'll be working with. You can stop for a moment, pause for a moment, and think about what I actually am predicting. In this example, you have all this data, all this audio, like streams of audio, and you also have my transcript, and you're trying to think like, wow, I need to find out a good way to associate audio with transcripts. And next, when you'll be building your data loader data set, you need to think about how should I split, how should I normalize, what should I do with my data so my model will perform the best. And this will inform your decision about, oh, well, maybe I should normalize, should I break them, what should I actually do? When you look at your data, the next step is you are building your dataset data loader class. And in our example, homework 1, part 2, we have 2 parts. We need to do something with MFCC files. We need to break them into individual frames. And we also need to do something with transcript. We need to break them into individual phonemes. And then basically, frames would be our X, and phonemes would be our Ys. Before doing this exercise, sometimes when you're building a data loader, you notice like, oh my gosh, like some different shapes, shape errors, or something happening. Sometimes it's very useful to have like a little toy example when you can just basically can trace all the changes you are doing in your dataset data loader class. Let's look at an example. This is an example, what are we doing basically to move from MFCCs to frames. Imagine you have just 2 files. One file is just 10 time steps and 27 features, just 2 files. Then you normalize them, your shapes do not change, nothing else. Then you concatenate all your files. So you had 2 files, 10 time steps each. When you join them together, you have 20 time steps by 27 features. Then you want to pad them. When you pad them, you just add additional context on top and bottom. So clearly your shape would change. Then you want, when you did all of the steps, you break them into individual frames. So if you had some like one shape, like a long file of different time steps, now you break them into individual chunks, the frames. Once you did this, you can apply to these frames. You apply in time of frequency masking if you want. Shapes do not change. Then you flatten, convert to a tensor, and you get the results, and then you can batch the data. So this is the steps that you could be following in your dataset data loader class to move from like one MFCC files into individual chunks suitable for training. Same goes with transcripts. So we load one transcript. We remove the first SOS and EOS at top and bottom. You concatenate all files together, convert them to tensor, change something, and just make a batches of data. So all of those steps are very like you kind of, some exercise you can have in your mind thinking about, yeah.
There's a question on Zoom which asks, why is result of step 1 2 lines?
Oh, this is a toy example. So in toy example, we just have 2 files. In your example, you have millions of different files. It's just for you, like if you're doing this exercise, it's easy. Oh, I have 2 files. Each file is 10 type steps, so 10 plus 10, 20. Like some mental exercise, but then in your original data, it will be way more different files.
One question.
Yeah.
When you say top and bottom, are we adding it on the feature or time step?
We added it both. Like here, when we concatenating all the files, first step we pad in them after we concatenated the files, so we have 10 time steps. We add context on top and bottom, and then when we do the frames, we slice the frames based on the context as well.
So the padding is based on the feature or based on the time frames? Like on
Time frames.
So it should be left and right, right?
Yes. No. If depending on how you shape your data. If your data is like, depending on like where your time step, where your features, but essentially on time steps. Yeah. And then once you did this, you had a bunch of files with different like unstructured data, and now you have like individual frames, and you can expect them, and you can see, well, this is my frame, one frame, and the associated phoneme with this. And so you will parse to your model multiple frames and ask the model to predict, like, to associate particular changes in MFCCs with a particular phoneme. Sometimes we don't want to pass one frame, we want to batch them, so we can have multiple options. So in option A, we have a batch size of 4. In option B, we have a batch size of 15. And sometimes we're asking on Piazza, oh, well, should I increase my batch size? And then you see like, oh, my RAM, like my memory doesn't like crash or something. It's sometimes because you're passing so much different frames and it's hard for your compute to operate them. So sometimes if you decrease the number of batches you pass, it's kind of very helpful. So you're batching next, so you build your train class. Now you have to move and build your test class. If you look at this on the left-hand side, you have all of the parts you're putting in the train class. We can go one by one and think like what actually of all of these parts is relevant for test class as well. So the first one is sorting. We need to sort data in test class, so we include them in the test class as well. Loading as well, we need to load data. Normalize, yes. Concatenate the files, yes. Padding, breaking, yes. But when it comes to applying time frequency masking, we do not want to do this in test class, so we are skipping this. And then flatten and return we keep in the test class. For transcripts, we do not need transcript in the test class. So if we compare them, our train class and our task class are very similar, except we exclude any time frequency masking from the task class, and we do not include the transcripts. And sometimes when we'll be your training and you will face some issues, like for example, your train and val accuracy is really cool, but test is really bad. The reason for that may be that your train and task classes are not aligned. So it's very important to like make sure like, oh, if you're doing some transformations in train and val class, you need to make sure that your steps, you're following exactly the same step in test class as well.
What is this masking that you're talking about?
Yeah, time and frequency, I will just literally show on the next slide about time and frequency masking that we are using. In a slide, yeah. Next, about context. Some of you are asking, should I add more context to my data or something? Here is the example. Can you guys guess what kind of context we use in all of these charts? There are 3 examples, 3 options. 0, context 5, and context 20. So in all of these examples, we just took the original frame and applied some kind of context. What do you think is option A? What kind of context we use here? What do you guys think?
20.
Who says it's 0? Who thinks it's 0? Okay, who thinks it's 5? No, everybody's saying it's 5. Okay, 20? Okay, one person. It's actually 0. So because when you look at this x-axis, you see it's basically, we didn't include, like, if we add in a context along the time axis, if we had 5, then like our time axis would increase, it's context 0. In a second example, it's context 5, and in the final example, it's context 20. And now when you add the context, do you think your model will perform better if it's more diverse features in context like 20 compared to context 0? That's why sometimes when you increase in the context, like reasonable amount, you might see the model improvement. Okay, it's about context. Answers. Okay, next about data normalization and transformations, asking your question. So here we have different data sets, different frames. Now, guys, you have to guess, which is the example of raw data? What is the example when we normalize the data? When did we apply time masking? And when did we apply frequency masking? What do you think, where is the, okay, option one. Who thinks it's a raw data? Nothing changed. Raw frame, okay. I think, yeah, majority of people. Yes, this is a raw data. So it's basically no transformations at all. I'm not sure, like if model, I think model will really struggle with this type of data. That's why we want to do something with it. Do we want to normalize them, change something? So it will be more diverse features. Option number two is a normalized data. So we normalize them, kind of better performance. And then two options on the right, we see like option C is time masking because we have time dimension and we mask certain time steps. And option D is frequency masking. We mask across wires. We actually covered this stuff in pre-processing video, but it's kind of very useful to see that, well, kind of visual. And if you're thinking, like sometimes you're thinking, oh, I applied some kind of transformations, and then you visualize, oh, actually I didn't. So like sometimes visualizing stuff can be very helpful because you can understand what's actually your model doing. Okay, and the final part about data set is sometimes you see these errors, like data loader exited unexpectedly or something. It's typically when you're using multiple workers in your data loader, and you'll see this error. So just simple thing, just reducing them. Okay, that was everything about data set data loader class. Do you guys have any questions for that part? Yeah.
Would you ever apply both frequency and time masking possible?
Yeah, sometimes when my model is really robust and really good, and I want to kind of regularize it a little bit and mask some of the stuff, I would apply both time and frequency. But it's kind of experimentation. You never know like what actually you should use. Sometimes you try to experiment and see what works. Yeah.
Can I go back to the example and explain 0, 5, 20, the example that you gave?
Yeah.
How do you say 0, 5, 20? Like,
how do I do, like, so I build how did I build these charts?
how do you say like?
Yeah, so in context, you remember this formula. So how we do pad the data? It's actually, yeah, we do 2 times context plus 1. So if we say context 0, it will be literally just 1 time step, maybe 2 time steps. If we add the context, we won't see just 1 time steps. We see something on the left and something on the right. So the context increased. And our data, when we parse something to the model, it won't just see 1 time step. It sees like what was before and what was after. So you can see it since we added context along the x-axis, we can see it on the x-axis. Simple math, yeah, math. Do you have any questions? Yeah, no questions. This part is really important, especially when you're working on your projects, brand new data set, and you don't know what's happening. It's kind of very cool, yeah.
There's a question on Zoom which says how to understand option A graph without any change to original data. So I think
this, how to understand, like.
How would you be able to decipher if A is raw or B is raw? I guess that.
Oh, okay. Well, I think, so you know, like the normalization, how the normalization works is like you should expect like some diversity in features. If you look at the option 1, it's basically something like in your y-axis is features. And you see at your features like 26, 27 is kind of like outliers of something. And the rest is kind of something else, so it's clearly it's not normalized. Yeah. Okay. Yeah, so this part is very important because when you build, you will be working on your projects, brand new data set. It's kind of very cool to kind of visualize and see like what kind of data you're working with. It will inform your decisions for model. Okay, building model. Okay. Next, for building model, the first very important stuff is to centralize all the hyperparameters. We have 2 options. In option 1, the person kind of hard-coded all of the values. And option B is kind of the person kind of created a proper config file and referring to the stuff. It's kind of very useful because if you think about it, option B is kind of better because if some new person comes to your file and tries to understand what actually you're doing, it's kind of very helpful for them to understand. So the way how you can build these config files, you can use 2 options. Option 1, you can build a config dictionary. Option 2, you can create a more fancy YAML file, but it basically serves the same purpose. Okay, next some interesting stuff about reading the model summary table. Can you guys tell how many parameters is this model? Amazing, yeah. The number of model parameters, great. Which layer is the most computationally intensive? Yeah, first layer. So if you look at this, we see that layer 0 has 2.7 million parameters out of 3.8. It's a lot. And if you visualize it, you'll see like it's kind of inverse pyramid. So you have the first layer has the most of like number of parameters, and it kind of decreases. When you build, like when you were working in your models, like on your homeworks 2, 3, and 4, sometimes it's kind of very important because like this would be a bottleneck for your computation. Some like layer would be so computationally intensive, it would take so much time to run, and you might want maybe to decrease them, to think about it, but sometimes it's very important to know like how to read those tables. Next. Here you have like the person faces an issue of different shapes, and the error says like shapes cannot be multiplied. The person wanted just simply had like 2 layers, wanted to include 1 layer, and faces this issue. Can you guys think about like why the person is facing this issue? Like if you just simply check the shapes of the layers. Yeah, go ahead.
That 512 and 1024.
Yeah.
Layer 1 and layer.
Perfect. Yes, perfect. So the person really wanted like, oh, I want like layer 2 to be larger, but like we need to make sure we match the previous layer because like everything flows. Previous input goes to the previous output goes to the current input. Great. Next, about batch normalization. We see this questions a lot on Piazza. So this person wanted to include batch normalization and simply copy in, oh, I want to batch normalization 512. And I will be using it in all layers. And then the person faces this issue. Why is the person is facing this issue? Who guys know? Yeah. Yeah, perfect. Perfect. Yes. So like the person, like if we normalize across the dimension, not like batch sizes, we have to make sure we can account for that as well. Okay, so this was model part. So basically how to read the summary tables, how to debug, shapes, matching, and everything. Do you guys have any questions for the model part before we move on to training?
You just go back one side. Okay.
Yeah.
I just need to see it.
Yeah. So here, like if we want to add, we need to make sure, like if we add in like batch normalization, different layers, just to make sure like to match them across the slides, across the layers. Okay, moving on to training and monitoring, interesting part. So imagine like everything runs, and now you're building your model, you log in into 1DB, and then it doesn't work or something. Let's try interpreting these charts. Do you guys see it? Okay, so this chart, the student getting this kind of chart, do you think, what kind of issue is the person facing? Let's think about it. It's kind of like was always there, like, yeah, no change in accuracy at all, yeah. What about validation loss and train loss? What do you guys think? What's happening in validation and train loss? People on Zoom can answer as well in the chat. Yeah, we kind of monitor that as well. It's kind of NaN. So this error goes like NaN error. So like if you see like, oh, I'm training and then sometimes my loss goes NaN, this is how it will look like. So basically there is no loss at all. And if you think like, oh, how to debug, so you go look at your learn rate, it's 0.1, it's kind of high. So the key issue is like the NaN issue. We can stop that, yes, we need to stop the training. We can reduce the learning rate, or maybe do some like gradient clipping or something. You can Google this thing as well. Okay, option number 2, what about this? What kind of issues, and should we stop the model or should we wait? Should we continue training this or not? What do you guys think? The first chart is training accuracy, the second one, accuracy, the second one is loss, and then learning rate. Should we continue this training? Should we wait? Should we stop? Should we give a chance to this model at all?
Stop.
Okay.
I think you can probably.
It's like depending on what you think. Like sometimes if it's just 20 epochs, you can just give this model a chance. Maybe for 5 more epochs. If nothing changes, you kind of can just stop and think about different model architecture. So like model doesn't converge clearly. You can try to wait. You can try to stop, whatever your preference is. Okay, next one. Okay, this is interesting. So what do you think about this one? Like, is it a good model? And should we stop training? Should we continue training? What do you guys think? Okay, how many people, okay, raise your hands. Okay, how many people wants to stop this training? Would stop this training? And won't give a chance. Okay, everyone like who thinks about we should stop. Okay. Who thinks we should continue this training? Okay. Well, actually, it's kind of a good thing we can continue this training, but the issue with that is we look at the y-axis of the first chart, it's kind of 30, and we expect to have like 60 or 70. So clearly some of the issues might be that the model is not complex enough, so maybe we need to stop, maybe we can stop this model, do something else, maybe increase number of layers, do something, because we expect like we want to reach like accuracy of 60 or 70, and our model is not capable enough to reaching this stuff. So maybe like at some point we can kind of stop and do something with it. In other cases, you might give a chance, depends.
There's a question on Zoom which asks, isn't the learning rate too low to contribute?
Oh, yeah, this is a good point as well. Yeah, great point. Yeah. Sometimes, yeah, the learn rate's kind of low, and we might think about learn rate scheduler here as well, because I think maybe it's like, it's kind of, yeah, too low. It's a good point. Great point. Yeah.
Also, just to add to it, it's like oftentimes on what we, since we are starting at a value of 0.1, but we tend to go to values as low as 1 minus 5. The graph can make it feel like you're now at a very, very low error, but it may not really be as bad, right? It could be 1 minus 3, and it would still look like this, because it's on a scale, it's much lower than what we started from, but in terms of training itself, 1 minus 3 isn't too low. So you could probably inspect that and decide based on that.
Yeah, cool. And also 0.1 learn rate is kind of very high. So like if you might want to start with a lower learn rate. Okay, next one. What about this? Any issues? Should we stop or continue training? Who thinks we should, okay, who thinks we should, do you have a question? Do we want to stop this training? Who thinks we should stop? Please raise your hands if you want. Okay, some people, okay. Who wants to continue training and things like keep them up? Nobody wants to give a chance. Okay, yes, this is correct. So the model clearly overfits. This is a classic way like to see like, oh, the model overfits. And also, we need to check both the first chart and the second one. Once our valid loss and training loss no longer decreases, meaning our model can reach its capacity. So we need to stop. At the same time, yeah, okay. And then the model clearly overfits, and then now we can kind of think about like, what should we do to kind of address this overfitting? There are multiple ways.
Quick question.
Yes.
The last one, how do you say it's overfitting?
Yeah. So first of all, we check first chart. Train accuracy is higher than validation accuracy, meaning train data is it cannot generalize well for unseen data, and our unseen data is validation data. So basically, our model is in its overfits. It's kind of trained so well for the trained data set that it cannot generalize to the unseen data.
Usually the loss increases for validation set, right? Then only we say it's overfitting.
No, loss. No. In the first, maybe I should mark the lines. But the blue line is a train accuracy on the first chart, and the orange line is a validation accuracy.
But isn't the training accuracy higher than validation?
Yes, but you should not see like huge gap. It should be, in the very first stages, your validation accuracy might be higher than train accuracy, but then at some point, train accuracy will just go above the validation accuracy. Yeah.
Just to add to this, it's like one thing that you can look at is the value of the train accuracy itself. It's crossed 90 easily. So that is one indicator. If that was at 60 or 70, you would probably consider, okay, give it a shot again. It's been almost 20 epochs and out of 40 plus where we're not really seeing a change. So it may not necessarily be outright overfitting, but as you said, we would definitely see the validation loss start increasing as well. So that is another thing to note. If you realize your validation loss is increasing, that can be a good indicator of stopping your training, right? If it flatlines, which it would many times, if it's flatlined for almost 20 epochs and the distance or the relative performance of validation and train is constant, that is when you can assume it to, if not overfit, the indications of beginning to overfit, right?
Yeah.
And there's not much more that you can extract out of it. So if for example, if your high cutoff is 86 and you're right now at, okay, if your high cutoff was 88 and you're just crossing 86, I wouldn't probably expect this model to cross 88, right? So I could decide to stop this, make changes, and then try.
Yeah. Sometimes you can, might want, so what you can do with this chart, you can first of all, if you're saving your checkpoints at every epoch, you can maybe come back to epoch 20 and do some changes and restart training or something, or you might start with a brand new model, whatever you want. So you might save this model, or you might start with a brand new one. Yeah.
There's another question on Zoom which says, why does the training accuracy and validation accuracy increase suddenly after step 20?
Oh, it's if you just check, sometimes it might be explained by the learning rate. At the beginning, the learning rate might be too high. Also, the person, in this example, made some modification to the data, kind of saved the checkpoint at epoch 22, made some modification to the data, to the model, and then restarted training. So typically just because the model itself changed. And we can do that. We can start with one model. Oh, it was performing good. Then we make some change, save this model checkpoint, make some changes, reload it, and continue training. So this is possible as well. Okay. Okay, so how we can also address overfitting? There are multiple ways. If you just Google it, multiple ways. The first and clear way is add more data. This is a classic example. If you take any machine learning classes, just add more data, it will reduce overfitting. Sometimes it's not possible, so we can move on to a different one. Adding normalization might help. Add in transformations, augmentations. Remember when we just did time of frequency masking? We literally masked part of the information that we trained on. It's kind of also very helpful because it it kind of teaches the model to perform really well, even though some data is not visible. We can also increase localization, so we can drop out, weight decay. We can experiment with that, do some error analysis. So once we did all of this stuff, we can print out our predictions, look at them, and just check. We can also try different model architectures. We can tune hyperparameters manually or using a grid search, running a for loop and just checking and trying different hyperparameters. It might take time, but it will be beneficial. We can do early stopping. We can also remove features. So there are multiple ways how we can address this. At the same time, there is no known way. So this is all of this thing when we have to build deep learning models. It's kind of a very exciting thing because you never know what kind of will work. You just have to try different things, cooperate in your study groups, and make sure that you will find an answer. Okay, and the final chart. Okay, what do you think about this one? So any issues this person is this model is facing, should we continue or stop training? What do you guys think?
Still high overfitting.
Wait, should we overfitting? Yeah, correct. Should we continue or
Stop
training? Well, I would say that if you just look, imagine the solid line is a train accuracy and the dotted line is a validation accuracy. And your goal in the homework part 2 is to reach the highest, your validation accuracy could be a very good thing. If you getting a good validation accuracy, it's a good chance that your Kaggle test accuracy would be good as well. In this example, you see that your validation accuracy keeps increasing. So it's a good thing. It's kind of steadily increasing. So you might keep it for a while.
Okay.
Because sometimes, I would say, if you will be working with homework 2 part 2s, when you're having the model will be more complex, you'll be running for many epochs. And even 0.1 increase in validation accuracy per epoch, you'll be very, very happy for that result. That's why sometimes, as long as it's not like this, kind of fully plateaued, you can continue running it.
Okay, yeah.
Yeah, thank you. And also learn rate, you can see it's kind of interesting. You have different opportunities for learn rate schedulers. In this example, you see people is using reduce and plateau with some different maybe the condition is oh, every my patience is 2, meaning every 2 epochs, if my performance, if my model is not improving, please reduce the learn rate by some amount. And it's kind of nice because it's kind of conditional, not just you have to increase for sure epoch 10, 20, and 100. You're just saying if my model is not improving, decrease it, but wait for 2 epochs. Okay, do we have any questions for this part before we move on to different other errors for interpreting charts and everything? It's kind of also very important to cooperate with your study group because the search space is a lot, it's huge. You have to check so many different parameters. If you could split them with your study group and check, it might be very, very helpful. Okay, moving on to different errors.
Yep, so now that we spoke about the different graphs and how we can interpret them, so I'm just going to brush up over the very common errors that might happen and very few hacks which you can use to sort of debug. So in runtime issues, I'm sure you will run into this in homework 2 part 2. Of course, first reading the trace back to find the root of the error is kind of obvious in order to debug stuff. And then you can also read the library documentation. One more thing is that sometimes the GPU will not tell you what error code happened. So you're supposed to set the batch size to 1 and then change the runtime to CPU in order to get a debuggable error message. We've seen this, I think, the last 3 semesters as well. You will run into this at least once. So it's kind of important to just set that, run it on CPU so that it actually emits an error message. On GPU, sometimes it does not. And then we just learned how to use PDB, and Stack Overflow should be your best bet to debug other errors. And now I think next would be, I think you already encountered this error in terms of like homework 1 part 2 when you got the error about CUDA out of memory. So here you would actually reduce the batch size, use mixed precision, the tutorial we provided you, and also during the validation and testing, you're supposed to have the inference mode set to be true so that the gradients are not computed. And also you can call the empty cache after every iteration of the loop if you like to free up any memory you might have. Usually you do not run into this if you use GCP or AWS, but in Collab you will sometimes run into out of memory. And I think sometimes here, there was another, so somebody in office hours yesterday for homework 1 part 2 used the batch norm that they had defined for homework 1 part 1, and it led to the training time for each epoch to be 18 hours. So it's kind of like, I think the Torch batch norm is much more optimized than the code we write. So that was one of the bugs that can happen as well. But coming back to this here, make sure all of your tensors and the model is moved towards the device so that it's actually making use of the GPU. And now you've debugged all of these things, and also your memory is fine, but it takes too long. One of the causes that I just told you was using your own functions. And if you're using a GPU, increase your batch size now, as long as the GPU does not complain. You must also check your data loader to ensure that you're actually doing the batching properly, because if you take just one sample at a time, that's also going to be slow, and most of the iterations happen. Mixed precision we've seen in the later homeworks helps a lot. If you use instead of float 32, float 16, and other things like that, that kind of makes the training faster. And you can use the time module to sort of count how much time each takes, but Collab automatically does that for you anyway, so that should not be a problem. And we'll just move on to the testing.
Okay, and so finally we continued, we did a lot of data loader dataset class. We finished the model, we made training, validation, and we got some decent result. And now we want to make a Kaggle submission, and a typical question like we saw in Piazza is like, how many rows should I have in my submission file? What do you guys think? Like, if there is like some stats, so we have imagined like the toy data set. We just have 2 files in train, 1 file in val, and 1 file in test. And there is a length of those files in the bottom. How many, like when you make submissions in the Kaggle, how many rows do we expect to have in our file, in the submission file? What would be a good way to think about it? Because sometimes you would do this and you'll have an error like, oh, Kaggle expected this number of rows, but you received something else. What do you guys think? Yeah. How many rows should we have in a test, sample submission test, and sample submission file? Yeah, so this is test data. So if we're training on train, making validation on val, and then in a test data set, we have different phonemes, and we want to make a predictions. The clear way to think about if our length is 1039, So clearly we need to make, for each row, we should make a prediction. So if Kaggle saying like sometimes we saw the Kaggle saying like, oh, it expects 1039, but you got 2994, it means that you kind of making your predictions on the train. So it's kind of very useful to see and double check what kind of data you have, what are the shapes of your data. Yeah. And then you submit and you see your Kaggle score and just very happy for that. Okay, so in the final one. So general strategy, how to do this whole model debugging stuff. Sometimes it's very good if you start very simple. Imagine you built a very simple model, everything runs, and then you can incrementally add more stuff, add more layers, add batch normalization and check if it runs. If it runs, fine, you can add up more stuff, but it's kind of not very efficient if you try to implement very, very complex model with so many different moving parts and then try to debug. So this incremental approach is very, very, very helpful. Okay, this is basically it. If you guys have any questions, we can come back we have 20 minutes. We can come back to the different charts. If you're asking, if you want to have questions about how to interpret some charts, what axis and Y's means. Yeah, do you have any questions? Any questions you have on your homework? Any, maybe some weird, 1DB charts you're getting, you have questions? Okay, yeah.
We usually get this error about this truncation error on collab. Like it just it runs my first epochs at about 50 to 60%, and then randomly stops saying that there's some truncation or some truncated error, and then I have to rerun the entire cell again. So why is that happening?
Well, first of all, how we would debug this. So we would look the error. I would need to see the error message, the trace of the error message, where exactly it happens, truncation in which part. Maybe it's related to data loader. Maybe something like how you batching your data and then applying tensor. It might happen in that way, but sometimes you would need to trace the error and see. I would assume maybe it's the data loader dataset class related stuff. Yeah, but you can post on Piazza and just post your snippets of your code, and we can look at this as well. Yeah. Yeah. Well, so we have mixed precision training. Yes, so we have this tutorial. If you go to the tutorial here. It didn't improve runtime? What was the runtime before and after? And even after you implemented mixed precision, it didn't change at all? Okay, so the first thing we can try to check if your mixed precision implemented properly. Sometimes even if you have mixed precision, you will still have long running time, so that may be connected to different other issues in the code. The way for example, data loader is a very important part, because the way how maybe you implemented the data loader a little bit inefficiently, so it kind of takes long time to run, to kind of load the data. What you might do is imagine, first of all, to inspect, to check is your mixed precision implemented correctly. If it is, then the first part to check is data loader class. Maybe add some time checks to see how much time does it take to load the data when you're just doing this. The what?
You save the data loader, you save the data into a variable, but you're not constantly fetching it from the files. Why would how you construct it?
No, because when you're making for every epoch, you're loading the data. You kind of loaded the data. You created the batches, and then you kind of load these batches to make a prediction. So it happens at every epoch. At every epoch, you're taking this batch of data, and you kind of running the model on that batch of data and getting the predictions. So it happens it actually, I had this question when I was taking this course as well. I thought oh, well, I loaded it once, so it should be fine. No, it's actually happening every epoch. So it's kind of important if you're especially working with large data sets, it's kind of very important to implement a very efficient way to load this data. Yeah, but we have office hours today. You can kind of go and we can check your code. But I think the way how I will do it, check the mixed precision, then check the data loader class, how it works, then check maybe how complex is the model, how many parameters. Is it maybe it's 40 million parameters. It's clearly kind of very difficult to do. Also the batch size. Larger batch size will make it faster. Also the compute, what kind of compute you're using. Is it T4, just to make sure you are using GPU. Yeah. any questions? We can come back to any,
Okay, so there's no question. There's one here, which is any suggestions on how to determine the width of each layer, and should the size be increasing at first and shrinks afterwards? So I guess this is
yeah.
structure.
I think we discussed, like, this was in a previous lab. We had different, like, shapes of our model. Sometimes it could be inverse pyramid. You never know before you try. So, like, we just recommend trying different things and just, like, see, oh, one person in the team would try, like, a pyramid way, other would try a diamond, like, shape. Some would try, like, very narrow. Like, you just trying things will kind of help. We never know, like, in advance what will happen.
Yeah, pretty much.
Should we guys come back to any of the slides? Any charts you kind of want to review? Any questions?
Okay.
No?
If
We can-
not, I guess you can always reach out to us on Piazza or attend any office hours. We have a lot of them.
And also, like, we're staying here. Like, if you have any questions, like, we're staying here till the class end. So if you have, like, questions for your debugging of your homeworks, we can also help. You can look at this mixed precision stuff. Yeah.
I'll just bring it over.
Yeah. Okay. The slides are posted on Piazza, and they will be posted on the website in an hour, I think. Maybe.
We'll also probably add a few additional resources which are beyond what we covered, just so that you all can read through and get in to read more fundamental stuff on how you can handle some errors and some different stuff that you can run into.
Yeah. Do you have any questions? Questions on Piazza? Did I say?
No more questions on Zoom.
Okay. Okay, fine. Okay, great. Then, yeah, let's turn it into individual office hours then.